Hey everybody, welcome back once again, or if this is your first time tuning in, I'm Squatch. We are working on a 1936 Caterpillar RD-6, and we are on episode number 20 of our, I would like to say restoration series, but have we been finding things? It's better just to leave the cover on there. It's a restoration attempt at this point. So if you're new here, first time tuning in, check out the playlist that I've compiled on the channel here of this project. The first 19 episodes are in order from start to most recent for a very convenient way to get caught up on everything that's happened so far. So, as promised in the last episode, it's puller time. That's right. And yeah, we have a pipe on there. So, we need to figure out how to pop this hub off of its tapered press fit on the end of the dead axle. So the area under the hub looks just like this side over here. Taper with a single key. That's where we are stuck. And yeah, we've got the spanner on there with the cheater pipe. Going back to the Caterpillar Service Tools manual, there is an operation in there where it shows how you can use that spanner wrench with a cheater pipe to push that hub off of that dead axle. So for an exploded view of what's going on, we'll look at the parts from the other side. So here's our hub. The press fit that we are stuck on is right under there. This is the spanner nut, and the spanner nut threads on the bearing cage. They call it the bearing cage because it holds the bearing and the race that is on the outside of the sprocket. And the way this hub works, there's a pinch bolt down here with a slit in the housing. So when that bolt is tight, this hub grabs onto the bearing cage and locks its adjustment, all right, prevents it from moving. So to adjust the bearings, you remove that pinch bolt, the hub releases its grip on the cage, and then you turn on the spanner nut, which will drift that cage in or out. The cage can drift inside the hub, but it can't rotate. So that means the tighter you turn the spanner nut, the more pressure it puts on the hub, because this hub acts as the backstop for the nut. So that's why we have a cheater pipe on the spanner wrench, and I've got the pinch bolt out, and I've cranked this spanner nut counterclockwise as tight as I can go, even with all of that leverage, and I still haven't generated the force necessary to pop this hub off of its taper. And this is really not that out of the ordinary. I've talked to a lot of people over the years, and they all say you rarely ever get these hubs off just by using that spanner nut. You have to find a way to put a puller on. So yeah, we've got the bearings piled in just as tight as they can go, but we still need more. And the only way we can grab onto this hub, we have a threaded hole here, and there's another one on the other side that this bolt is in. This is my test bolt. These are a 9/16 by 12 thread pitch. Odd size, yes, but we are talking about Caterpillar after all. So I can run 2 bolts into this hub, one on each side. So we just have to make an adapter that will utilize these bolts, those threaded holes, and that I can also attach, I'd say, my 30-ton hollow ram to, so that we can use that in conjunction with the pressure that is being applied by the spanner nut and see if we can pop this hub. It's going to be some work, but I think I have a plan. So we'll start with this steel disc. It is 2 inches thick and 10 inches in diameter, and that may seem like overkill right now, but my plan is to make this suitable for at least 2 different pulling operations, so it won't just be a one-trick pony. So that's why we need the real estate and we need the thickness if we're going to throw 30 tons on this and have it not deform after we drill holes in it and whatnot. And the first hole is also going to be the biggest one. We need to take the center out of this disc so that it can slide onto that hub. This is 3 1/4 inches in diameter. And we are drilling. That's right. This is not me showing you how it's supposed to be done. This is just me showing you how I am going to do it. Those two things are usually very, very different. But I'm just drilling a series of holes around the perimeter of the main hole. So this is just a regular spiral drill bit. Here, I'll turn it off for you quick. once I get down there a little bit, I always give it a little shot of cutting oil. This is just a regular spiral drill bit. And we have a series of holes that goes most of the way around. You can start to see them if I get the chips out of the way. So we'll just keep drilling. I locate the hole just by eye, lock the table down, get all the way through. And then reset. So now that it's calmed down a little bit, yeah, see all the holes I've been drilling so far. Oh, real machinists everywhere are probably just having a fit right about now. That is not how you do that. That's all right. Oh, the mischief I can get into with a Bridgeport, let me tell you. Okay, lock the table down. We are ready to drill another. Now what I'm doing is taking an end mill and just joining all the individual holes so that it becomes more like a slot. And I'm also leaving webs at, we'll say, 12, 3, 6, and 9 o'clock for now. Just keeps the center slug better supported. Those will be the last 4 that I take out. And then, you know, we might break an end mill bit when it comes to that. But we'll cross that bridge when we get there. Okay, so I've made it all the way around and I'm taking the holding webs out, but not completely. I'm going down and leaving probably only about that much at the bottom out of about, you know, that much overall thickness. I don't want to explode a bit. If we let the center slug get too loose, it can rock and then jam and then pow, there goes the bit. So I'll try that, take it most of the way down to the bottom and then probably just, you know, finish it off with the hacksaw or something. There. Oh man, it's too heavy for the magnet. Let's see if we can dig it out. There. Now, it would have been a lot quicker just to drill the center of that to the largest bit that I have and then take a large end mill and just turn it all into chips, but I kind of wanted to have that slug. I'm sure I can find a use for it somewhere. And now I'm using this fly cutter to true out the inside of the hole. We're extended out pretty far, but with the interrupted cut and rough surface, I'd rather tear this tool up than anything better. It'll work. Center hole cleaned up well. So, oh yeah, we're making messes. What can I say? Get it off the table. Move on to the next step, which will happen on the old South Bend lathe. I have this placed in the chuck so that the center hole runs true, and when I spin this, you'll really see how rough the outside of that blank is. See how it jogs up and down, bumps and dips. It's in rough blank form, even though it is a 10-inch diameter blank. We're a bit oversized, so we'll just clean this outside up and get us right down to around 10 inches. That's where I need to be. And make no mistake, we are taxing the old South Bend here. Batting over our heads for sure, but here at the Squatch Plow and Machine Company, our ambitions are always bigger than our equipment. Taking it right down to the last little bit, trying to reach across the face. All right, that should give me my 10-inch diameter, and I have just one skip left in it right there. But that's no big deal. That will be cut out when we go back to the milling machine. And as long as I have the blank all centered up in the chuck, I'm going to face this end. If anything, just to make the setups more accurate in the milling machine as we move forward. Otherwise, it doesn't really need to be faced off, but it's just something, it's going to make the part more uniform. I have our blank clamped back on the milling machine table again. I used this tool to scribe the center line right down the blank as long as everything was still round. This center line is going to be used to position the drill holes for the 2 bolts that will thread in from each side and grab onto that hub that we're trying to pull. So the next step, let's see if I can get you all where you can see it. This scribe line that goes right along here, there's one over on the other side as well. Everything to the outside of those scribe lines has to be taken off. So we're going to make a flat on this side and another flat on the other side. Okay, done with the milling, time for the drilling. Just gonna make sure, yes, that center punch is located well. Yeah, we're chewing it down. No more raw edges left now, it's all shiny. But yeah, 2 flats. I thought about just making a notch that the bolt can drop into and having material up on each side, but then I really didn't need it. And having the notch this deep already with a hole drilled through, I'm still as strong with all the material removed to make these wide flats as I would have been if I would have left that surplus on each side of the bolt head. Okay. Plus, having everything so nice and flat like that, I can clamp it right down on the table. I can drill square. It sets itself up so much better having 2 nice flat edges on it. So let's drill the holes for the bolts. I was hoping to get all the way through without stopping, but I have to clear that mess. Where you want to be careful too, because these shavings can really cut you. That's better. Now we'll finish it off. Boy, we have to just about be there. Yep. And it looks like our 2 holes were drilled right in alignment. You can see right through it. The 9/16 bolts feed in from either side, and that's where we grab onto that outer sprocket hub with the adapter. 4 holes left to drill before we are done with this piece. The 2 larger ones right here and right here will be drilled and tapped for 1 inch by 14 threads. That will allow me to attach my bar puller legs to the adapter. The other 2 holes, they're a little closer in, one here and one here. They just need to be clean pass-throughs for these 5/8 bolts. And this is where I hope to get a second pulling function out of this same adapter. I mentioned at the beginning of the episode, I want this to be more than just a one-trick pony. Just this raw blank of steel alone was $200-ish, and we want to get as much use out of it as possible. So the reason for those 2 bolts, well, I'll show you. It just so happens our 3 1/4 inch center hole is already the perfect size for this second job, and the way I made this 10 inches across at the major diameter should allow that same adapter to fit the faces of these final drive pinion flanges. So our center hole will clear that hub, and at 10 inches major diameter will nestle right down inside of that ridge and still be flat up against the face. And the 2 5/8 bolts are for the threaded hole right there and the threaded hole right there. Now I'll be able to take these holes most of the way out on the bridge port here. But I'll have to finish them out on the old Camelback. It isn't fast, but it drills holes. It's a neat old machine. And now we set up for the final step on this piece, and that is tapping the threads. 1 inch by 14 tap, and I have the tap guide in the spindle. Spindle's been recentered to the larger hole, so we're nice and square. Yep, and that will start us in. The thread cutting oil, I end up using plenty when I'm cutting fresh threads like this. I get it all over everything. Yeah. And we'll reapply as needed. Get it to start in just a bit, and then you always want to reverse direction and back that chip out with this style tap. So it's just back and forth. Chew in about a half turn at a time. Go deeper and deeper until we come out the other side. And after some cleaning and deburring, I believe we have our adapter finished. It looks good. Hopefully it works just as well. I'll be using it with a 30-ton hydraulic ram and the straight bar puller. Now the puller legs, the factory made ones, I'm not going to use because they have a shorter thread on the end that will only engage with half of the threads that we have in the adapter. This high strength 1 inch by 14 threaded rod, it will grab all of those threads. So we'll use these instead. So, all right, let's start assembling it out on the machine and see how it works. All right. Step one, obviously, is bolt the adapter to the hub. There's the hole. I can already tell you these bolts are going to be our weak link with this setup. But this is the only way I have to grab onto that hub, through those 2 threaded holes. So hopefully it'll pop before it just acts like a metal shear and cuts the ends of the bolts off and leaves them in the hub. We'll just see what happens with it. This is all trial and error. Yeah. It's good. I know these threaded rods aren't going to be the first ones to tap out. And hook our pressure line up, and we'll be ready to see if we pull it. See it tightening up. There it is. Look at that. Popped at about 7 tons. Not too bad. All right, pressure off. Catch nut caught it. Yeah, so it was just a little bit more than what that spanner nut could do. All right, that one works. There's the hub. Spanner nut, bearing cage, yeah. So now we tested on the pinion flange. I have this one removed, but it's just right here. You can remove the whole pinion shaft and bearing cage and flange and everything from the case. That's how we have it here. There's our pinion gear and the bearing cage and all that. The flange is still pressed onto the shaft, and these are supposed to be pressed on at 30 tons. I get the impression from old stovepipe here that none of this stuff was actually pressed back together the last time they were into it. So these might be some pretty light duty tests. We'll just have to see. These two bolts attach the adapter to the pull holes in the flange. And I didn't discuss this part when I was building the adapter, but you might be wondering, why don't you just use threaded rod to go right into the flange and up to the bar puller? It's because my 30-ton ram won't fit between them. It covers both of the heads of those bolts. That's why I had to use this adapter for this purpose as well. And it really wasn't that much extra work. I was already building it for the hub, drilled 2 extra holes, and it fits everything perfectly. You got the catch nut down in the center. Yeah, it's going to work pretty well. If you had a smaller diameter ram, you probably wouldn't need an adapter like this. But in my case, I do. And we're set up to pull again. Just taking up the slack. We really don't have any pressure on anything yet. Making sure everything is well centered. It all looks good. Okay, now we're starting to build pressure. 5 tons. We got 10. Okay, that was about 20 ton. I think it let go. Let's see. Yep, we got it. There was our press fit taper. That's the early diesel 40. 2 keyways. Okay. Flange puller works. All right. Excellent. Excellent results. Well, I'm happy. I like it. This episode took quite a bit to put together. It doesn't look like much. There was a lot of sitting and thinking and then changing the design and then having to order more things, and it took some time, but it works very well with the 30-ton Ram. Like I said, I think old stovepipe diesel 40 was a little bit of an easy go. When we get into old frosty diesel 40, that one looks pretty right proper. So I think if anything's going to be really tight, we're going to find it on that one. But so far, it's solid, fits well, and it does the job. So this has been the pulling adapter machining episode. I hope you all enjoyed it, and I hope to see you all back for the next one. Thanks, everybody.